Okay, this is a review part of 3. So let's share everything, including calculator. All right, so let me open Tempus City AP Stats. And I guess assignment 36 is a chapter 7 test. So I'm going to create tonight. Okay, so let's see. This is test review. So I think in the first video I asked you to enter this. Second video, maybe you create the histogram and also the one variable stats test. And we describe what these. And also I think we have probabilities of the 50 batteries, and we try to get this percentage of this highlighted area. Okay. And we discuss if it's suitable or not suitable, okay, to run this. Okay, number 4 and 5 is left over. Number 4 is assume that the actual proportion of unsuitable batteries produced that day is proportion, right? Equal to 0.27. Describe the shape, center, and spread and sampling distribution of p hat of random sample of 50 batteries. Justify your answer. Okay, so if it's random samples of 50 and of the p hat, right? So this is sample proportion is going to be run on this equation, right? So let's, before we run, let's see, it's less than 10%, of course, 50 batteries are. And this is chapter 7-2. We have to run how many counts of success and failure. Success means unsuitable batteries for, it's weird to say that, but and failure is a good batteries, right? So so let's run this 50 times. Let me clean up. 50 times 0.27 is 13.5, and so the other one is obviously times 0.73, I guess. So that it will be more than 10 as well. Both of them more than 10. Both of them are more than 10. So in that case, we can run this one, and as it's going to be normal distributed, normal distributed, right? So and standard deviation of this is going to be use this equation. Now, I highlighted this condition right here. This, so maybe I should cut and paste. Okay. Okay, so let's see again. So this one is going to be cut and paste here. I can go down. So it is less than 10% of all batteries, and condition counts at least 10. So counts, these are counts. This is the orange one. And green one is so obvious that it's going to be less than 10% of the all batteries. Okay, all, it could be all WA, right? Those WA batteries. Okay, so now let's run this. Oh, sorry, hat's supposed to be in it. So on. P is 0.27. The failure is going to be 0.73, right? Complement of this is 0.73. So let's run this. So square root of 0.27 times 0.73 divide by, and divide. delete. So forgot to start with black. Okay, so this is okay. 0.27 times 0.73 is going to be the numerator. So within this, not within, but so I put the division sign here within the square root sign. So square root or divide by 50. Okay, I will enter this. So this is a new standard deviation. Standard deviation of p hat sample. What do you call? Standard deviation, sampling distribution of p hat standard deviation. So that's all this. Yeah. 0.0623. Let's round up near 1,000. Okay. 0.0623. Okay. So I'll remove this one and p hat is going to be okay. So let's use this. Now what you have to do, number 5. Okay, so shape, center, spread, sample distribution, p hat. Okay, shape. So this is going to be normal distribution. Center is going to be center at the mean, right? And spread. Oh, center at the mean means proportion. So it's going to 0.27. So 0.27 is going to be at the mean. No outliers. And spread, so spread, it could be range, but more likely spread is the standard deviation. So standard deviation is going to be 0.0623. Okay, so let's read number 5. I will keep this one here. All right, find the probability of obtaining the random sample of 50 batteries in which 32% or more of the batteries are unsuitable if P equals 0.27. Okay, show your work based on your answers. Should the entire batch of batteries be shipped to the customer? Why or why not? 10 random samples, 50 batteries is in 32% or more. Okay, so that day we had was this 16.178, I guess. So nothing to do with 16.1, but let's see, I wonder if it attached to it, but 32. Okay, so we have to think 32%, 0.32 is gonna be the asking probability. Okay, that a little confusing. All right, so let's see. So let me get this thing right here. The question 5. Right here. And paste. Okay, I got the normal curve. So what you have here, the p hat right here, 0.27. And according to our rule, you have to put n for normal model, and 0.27 is p, sample distribution p hat actually, right? And standard deviation 0.0623. Okay. Right. So let's see, one standard deviation above, and just roughly, it's gonna be kind of more steeper, I believe, because of sampling distribution. Let's see, we don't know. So just roughly 0.27 plus 0.06. One standard deviation above is 33. So if it's going to be here, put that dotted line, 0.33, what? 3323. It's going one standard deviation above. What the cutoff line that they were talking about on question 5 was 32% of. Okay, find the probability of obtaining a random sample of 50 batteries in which 32% or more of the batteries are unsuitable. So if I highlight, if I come up, solid line will be the cutoff line. So around here maybe. And I will change this by color red. And I will highlight above, right? So it's going to be this highlighted area this question is talking about. Let me read it again. Find the probability of obtaining random sample of 50 batteries in which 32% or more of batteries are unstable if the P equals 0.27. Show your work. Based on your answers, should the entire batch batteries be shipped to customers? Why or why not? So most likely, if this is not acceptable batteries, and this white section is okay, maybe we can send the batteries, right? Since this is a sampling distribution anyway, right? So let's see, normal CDF, clean up. Second, normal CDF. Cutoff line was 0.32. Upper is infinity 1 E 99. Mu is 0.27. Standard deviation was 0.0623. And let's paste. Okay. The yellow highlighted section area is 21%. So I think it's based on my answer, those answer highlighted section is 0.211. Yeah, there's a calculation. You can run the z-score and calculate, or you can write down this and including normal CDF TI-84 code. Entire batch of batteries can be shipped to the customer because it's, let me read the model answer. Okay. There is about 21% chance that in random sample of 50 batteries, 32% or more would last less than 16.5 hours if the process is working correctly. because this probability isn't very small, there isn't convincing evidence that the proportion of unstable batteries is greater than 0.27. It is plausible that the process is working correctly and we got a sample proportion of 0.32 by a chance alone. Thus, the entire batch should be shipped to customers. Okay, so that's the model answer. So that's the uh, end of your test review. So good luck of your test and good luck studying. Okay? Have a